In this example, we're given 4 points, and we want to try to figure out how to name that quadrilateral. So we'll plot K at 1, 4, and that's over here. And then we'll plot J at 3, 6, and that's over there. We've got L at 3, 1, and then M at 5, 4. And if we connect those, I hope it's windy because it kind of looks like a kite. But what we want to do is we want to mathematically prove this using our super awesome math skills. So we're first going to find the slopes of each one of those line segments. So we've got KL, LM, MJ, and JK. But I'm not just kidding. Okay. All right, let's do KL. So to go from K to L, we're going to go down 3, right 2. So down 3, right 2 would be -3 over 2. How about LM? LM would be down 3, left 2. So that's down 3, left 2, which is +3/2. Now you might be looking at that and saying, I wonder if those line segments are perpendicular. And if you look at the actual figure, it's pretty believable that they're not. And we also know they're not because those slopes are not opposite reciprocals. It's true they're opposite, but they're not reciprocals. So those line segments, KL and LM, do not meet at a right angle. Let's move on to MJ. So we're going to go up 2, left 2. So that'll be up 2, left 2. And 2 divided by -2 is -1. JK is up 2, right 2. So that would be +2 over +2, which is +1. So once again, even though, those are perpendicular because those are opposite and reciprocal. One is kind of a funny one where if you take 1 over 1 and you flip it, you get 1 over 1. So those line segments are actually perpendicular to each other. But that doesn't really matter too much for a kite, which we're thinking this might be. So what we need to do is really check our distances here. So we'll work with KL first, and we'll use the Pythagorean theorem here. So KL has a triangle with a couple legs, 3 and 2. So we'll do 3 squared plus 2 squared, which is 9 plus 4, or 13. And of course, that needs to be under the radical sign. If we look at LM, LM has the exact same setup, the exact same triangle, so we know that LM is also going to be the square root of 13. MJ and JK are going to be a different measure, and we're hoping they're the same. So let's do MJ. So we have 2 and 2. So we're going to do 2 squared plus 2 squared underneath the radical sign. 2 squared plus 2 squared is 8. And if we break down the square root of 8, we can break that down into 4, or the square root of 4 times the square root of 2. And the square root of 4 is 2. So we can fully simplify our answer as 2 root 2. You can double check your work by typing the square root of 8 in your calculator and typing 2 root 2 in your calculator. They should be the same decimal. JK has the same triangle here, 2 and 2. So that hypotenuse, which is the distance between J and K, is going to be 2 root 2 as well. Now we know that adjacent sides, that means sides that share the same point or the same vertex, that those adjacent sides in this shape, those are congruent, or they have the same measure. So we know for sure that KLMJ is a kite because 2 pairs of adjacent sides are congruent. And that's all you really need to write for a kite.